And perhaps most troubling, why this frog? Why not others? Closely related species die at temperatures well above freezing. The wood frog alone walks this edge. Its range stretches into the Arctic Circle. It breeds in meltwater pools that exist for mere days. Has evolution sculpted it into a creature of temporal extremes? A living question? Some researchers believe this could rewrite what we know about organ preservation. Cryonics, space travel. If a frog can survive without circulation for half a year, what might be possible for us? But others caution restraint, because for all we've learned, the full picture eludes us. We don't fully understand the timing, or the margins, or why some survive and others don't. In one study, nearly half the frogs subjected to controlled freezing died anyway. The mechanisms are fragile, not magic, not replicable, yet. Still, the idea remains, haunting, echoing. That death, at least as we define it, might not be final. In this creature, nature whispers a different story, one not of defeat, but delay. Not a period, but a comma. And so we're left watching, waiting, for a leap that defies biology, for a heart that starts after silence. Is it resurrection? Is it something older? Or is this simply what life has always known? That survival sometimes means letting go of life and trusting it to return. It begins in silence. Beneath the snow-packed floor of a northern forest, something unnatural lies still. Limbs rigid, skin dusted in frost. Inside its tiny chest, nothing. No pulse, no breath. Veins are clogged with ice crystals sharp enough to tear flesh. Its cells, shrunk and desiccated, resemble something more fossil than flesh. A body suspended. Not asleep, not in hibernation, but cold, dead. And yet, come spring it moves. First the limbs loosen, then the chest rises, slow, shallow breaths returning. Blood somehow begins to flow again. Within hours the creature is gone, leaping back into the woods, as if death had been no more than a pause. Biologists have recorded this for years, observed it, measured it. Some say they understand the mechanisms, but the truth is harder to pin down, because we've never seen anything else like it. A full-body freeze, no heartbeat, no brainwave, no oxygen, and then revival. What is this animal? What is this state? And if it isn't death, what is? We thought we understood what cold meant for living things. That freezing is a sentence, irreversible and absolute. Ice doesn't just stop life, it destroys it. The sharp, crystalline edges shred cells from within. Fluids rupture tissues. In warm-blooded creatures, even a few minutes without circulation leads to catastrophic damage. For years, this was unchallenged. Winter meant retreat or perish. Birds fled south. Bears slowed into metabolic slumber. Rodents built entire societies underground to avoid the cold's lethal reach. But then, this outlier appeared. A small amphibian, brown, speckled, seemingly ordinary. The kind of creature that might vanish into the leaf litter unnoticed, and yet it does the unthinkable. It doesn't avoid the cold, it embraces it. When temperatures plummet, it buries itself just below the forest floor, not deep enough to avoid freezing, but exactly where the frost hits hardest. And there it waits. In the lab, researchers placed thermal sensors on its body. They watched the readings drop past freezing, watched ice form in its limbs, its torso, even its eyes, watched the heart stop for hours, days, weeks, and then, when the thaw arrived, they watched it blink, hop, live. What's more, this wasn't isolated. It happened over and over. There are records of individuals surviving temperatures as low as -16 degrees Celsius, of being frozen for 7 months and walking away. And not just surviving, but thriving mating, feeding, acting like nothing had happened at all. The deeper we looked, the stranger it got. Inside its body, certain things did freeze, its blood plasma, the fluids between its cells, but others didn't. Its vital organs remained sheathed in protective compounds, natural cryoprotectants that lowered the freezing point, preventing fatal ice formation. It was as if the frog chose where the ice could form, letting it creep into the margins, but never the core. Even more bewildering, its body prepares for this. As autumn sets in, it begins to accumulate urea and glucose in massive concentrations, levels that would be toxic in most animals. Yet here, they act like biological antifreeze, holding water inside the cells, preventing rupture, slowing time. But even with these defenses, the feat borders on impossible, because we're not just talking about suspended animation, we're talking about death. No signs of brain activity, no heartbeat, total metabolic shutdown. By clinical definitions, this frog dies. And yet it comes back. How? This is where certainty dissolves. Some theories point to gene expression, that certain hibernation-linked genes activate only in extreme conditions, triggering the protective cascade. Others suggest it's not the genes, but the timing, that the frog's body must slowly enter freezing, layer by layer, to avoid thermal shock, that a single wrong signal, too fast a drop, too sharp a thaw, could shatter the illusion of control. Then there's the question of the brain. In every other animal, minutes without oxygen mean irreversible neural damage. But in this creature, the brain survives hours, days, even weeks without blood flow. Does it possess some ancient neural shield we've yet to discover? Some redundancy in its wiring that keeps core memories intact even after apparent death?